But I'll show you guys the idea of what I kind of want to implement here in just a second. So cd, they might want me to run npm install before I get that booted. There we go. So kind of just have this. The idea here is that you can go ahead and add a restaurant, call it something, give it some menu items, and then save it. None of these buttons are stylized or anything because the main idea that I want to get at is to create a database that's going to store all these different restaurants. And then so you can have a CRUD application if you don't know what that is. That's create, read, update, and delete. So then you can do all of those different functions and then update this as necessary. So that's kind of the idea here. I already have a little bit of something set up. So if I go into the backend here, so cd demo there, backend, and then I run node. I'm gonna run npm install here because I think I used a couple important packages. Yeah. So if I node server.js, that's going to be running the server here. So that's more related to what we're going to be implementing. Right now, all that's there is a bunch of these endpoints. It's reading the data from this dummy data JSON that I wrote, essentially just has some like fake data for this burger barn place in Pasta Palace, right? So nothing really interesting there. This backend, I don't want to go too much into Node.js, but essentially what you have is for each one of these app.js, sorry, app.gets, those are GET requests. So essentially saying that if you ping the endpoint slash restaurants, so if I scroll down here, I think it's port 3001. So if I go to like localhost 3001 slash restaurants, that's a GET request for all the restaurants. So this is going to return you a list of all the restaurants. There's another GET request here. Actually, no, there isn't. There's a post request for posting to that restaurant. So adding a new restaurant by clicking on that add restaurant button. There's a put. Put is essentially like update, right? So like I said before, CRUD stands for create. Create is essentially get. It stands for read. Read is essentially post. And then there's delete for D, and then U is put. So essentially like updating if it's already there. Um, like whatever element or restaurant that you want to edit. So I kind of have those four different aspects and then essentially just reads from that dummy data file. The issue with that is that when you have lots of data, let's say hundreds and hundreds of restaurants that you want to put into this, obviously this is just like a silly little demonstration, but if you're working with like Netflix, right, each movie is probably, I don't know, like 20 gigs or so, probably even more than that. And then there's all these different customizations that you have to make. I think Netflix uses AWS to store, or maybe they use Microsoft Azure. But there's all these like different cloud technologies that help you store stuff in databases. But the more basic way to do that is to use a database, like a database. Like MongoDB, PostgreSQL is one. There's several others out there. But the idea behind Mongo is that Mongo is this website over here, Mongo Atlas. You can store Mongo locally or you can store it in this Mongo Atlas. I believe this is cloud-based. Like this is being stored in some server somewhere out in the middle of nowhere. I think it's actually in Virginia or something like that because I had to add that in the configuration. So it's stored in some server out there. And then I create this cluster, which is essentially a database in here. I can show you how to do that just if you want to replicate it. They only let me use one free sort of cluster, so I'm not actually going to create the deployment because I don't want to get a 50-cent charge. But you would essentially set your region. Right now, this is set to DC, or North Virginia, right? You would name your cluster, and then you could set these to different things. Like I mentioned before, AWS, Azure, those are different cloud platforms. Google Cloud, another one. But I think AWS, most people have heard of that. That's a really big one. Um, so that's what I went with for this. It doesn't really matter. But essentially, that's just saying that this is the cluster, the database that I'm creating, and then I need to use this sort of database to add and edit instead of that dummy data.json file. So if I go back here, hopefully this code started running. Yeah. So if I reload the page, you can see pasta place, burger barn, and burrito boo boo. I don't know. Whatever I inputted there, right? And if you want to edit this, um, I'll call it like ABC123. I'll call this food 22 and 2. Sure. Right. So if you save that, that should log it over here. I think my shadow's covering it, but you can see that we edited those items. You can go ahead and view these items that I created. But if I reload the page here, you can see that it saves because I'm storing all of this into a JSON file. If I go to that dummy data.json file, where did that go? Here, right? If you go to that dummy data.json, you can see the updates live there. And this is basically a local database if you think about it. The only issue here, again, like I said, is scalability. If you want to throw thousands of these, that's not going to work, right? It's going to take an extremely long amount of time to, if you look at, let's see, server.js, this read data function, if I just control F read data, this is called 5 times, and each one of these different endpoints, I'm calling it once. If you go to this, this is reading all of the data. It's parsing through a JSON file, reading it as raw text, and then uh, like loading that into some sort of data structure that the code ends up using for everything. So that's kind of how that works internally. We don't want to do that every single time. There's definitely a better way of doing that, and then that's definitely to use a database for this. So that's what I'm gonna do. So if you again, if you want to skip to completed, that's all there. For some parts of this, I might just copy paste it just because it's really annoying to write. But I do want to kind of work through this from scratch. But for the app.js, there's a couple changes that I'm just gonna copy paste. Essentially, it's more front end related, and like pinging each one of these. Here, you're using like this fetch request for this endpoint. I just want to change that so then it's pinging the GraphQL server instead. So if I go to like the completed branch here and then pull that out, and I'll just go over the changes that I made. This will make more sense when I do the actual GraphQL stuff. But the point of GraphQL is instead of having all of these different endpoints that are all set up throughout your backend and everything like that, I'm just gonna have this one backend point, this one endpoint called 4000 slash GraphQL. And then this will give you all of the information that I need. So if you were to do this just plain MongoDB, you would have something like restaurant dot I I'm not spelling that right, dot ID, right? And then you'd have like another endpoint and another endpoint to get like restaurant, to get menu items, to edit menu items, just like we had before, and that becomes a really annoying hassle. The idea behind GraphQL is that you're adding an additional layer on top of that, that essentially lets you do something like this. You essentially plug that query straight into your front end. So instead of having like SQL code, like you could have like a insert into database and then whatever you insert into the database based on your schema. In the back end, all you would have to do is this sort of query text in there as a string with all the necessary parameters here, right? And then you can call this like set restaurant function here, and then that's gonna update the list of all your restaurants. So then even when you reload the page, it stores that information in the database. So that's kind of the main change here. As far as this is more front end focused. I want to more head over to this backend folder and then change some things there. The first thing I want to make is this models folder. Um, and this is going to be storing the straight schema of everything. So give me 1 second. Yeah. So in this models folder, I want to create a model, essentially like all the information that the restaurant itself is storing, JS, and then I'll import Mongoose here up at the top. And I think I need to npm install that as well. So front end, npm install Mongo, I think it's Mongoose. Um, and I think GraphQL as well. So hopefully that's the right thing. So yeah, in here, what I essentially want to do is to create two items. There's the menu item schema and then the restaurant schema. I think this AI thing is suggesting it for me, but I'm just gonna start with the menu item schema. And okay, there we go. Um, Actually, we don't need all of this information. All I really want to have in here is that this is a string, right? So the name of the menu item is a string. And I also want to throw in a price there. A price is a number object, just because that's how Mongo wants to deal with it. And then the last thing is the description of that, like something that goes with the menu item, detailing that. Um, did I get here? Oh, yeah, one comma there. And then the next thing that you want is a restaurant schema, which Copilot's also giving to us. And then the same information here. Um, yeah, I think it has access to like the completed code, so it's in a way copying that over, which is nice for me. But just to explain this, uh, a restaurant schema is going to have a name, an address, and menu items. And the menu items is a list of these menu items object that we created up there. So think of like a class object, right? So same idea there, nothing too different from the norm. The next piece of the puzzle here is the schema dot JS. So that's going to go in this backend here, schema dot JS, right? This is the first use where we actually need graph SQL. So I'm gonna call that, and that's from something called Apollo Server Express. It's just like the package that is called. And here I'm gonna have this gigantic thing. Actually, I'm tempted to just copy paste this because it's incredibly long. But here, let's see. So then you have Oops. You have a menu item, right? Just like we had before. This is essentially creating that extra layer that we call an app.js. So notice how you have like ID, name, address, menu items, all these different informations. You want GraphQL to know that as well. So then that's why we're creating the schema over here that's using that model and kind of building it out on top of GraphQL. So you have menu item. That menu item is going to have a name. It's going to have a string. It's going to have description, and it's going to have a price. All this exclamation mark means is that it could be null. So it's kind of saying, is this item required or not? Like a is required field essentially. Okay. So the next thing that we want is to add the restaurant object, which it's going to do for us as well. Um, so there we go. So a restaurant's gonna have a name, ID, address, menu items, etc. The rest of this is basically just more busy work, right? So you have your menu item, you have your restaurant. The next thing that you want is a query object. So the query object is essentially saying, when we go over here, this query object is saying, when you call query, what do you want to happen? Like, what's the actual function of that query? Um, just so I'm not like constantly typing, I'm gonna copy paste that over and then explain what's going on. So backend schema. Yeah. So there's really one important thing in here. Again, menu item input, that's just the same thing. Menu item's gonna have a name, description, and price. Restaurant input's gonna have a name, address, and menu items. just basically copying this over into something that GraphQL understands. The only important thing here is a mutation. And these are where we're defining what types of queries that we're going to have. So up here, we kind of said query is containing restaurants and a restaurant. Uh, but in mutation, we're having the three different functions that we're going to have here. The first is create, update, and delete, right? So kind of creating the CRUD application there. A read is the same thing as query, right? Because that's telling us, it's like reading from the database and then telling us what's in there. But apart from that, you have the C, the U, and the D. That's going to go in this mutation object. The reason for that is because it's actually updating the list. Like when you do any of these three things, your database is changing, it's mutating in some way, right? So we're going to have create, that's going to take in an input, that input object up here that we already formatted, and then that's going to return a restaurant, the restaurant that it created. Update's going to do the same thing. It's going to take in an ID of what you're updating. Each in any sort of database system, whether it's GraphQL or Mongo or anything, every item is going to have a unique identifier, just because that's just how a database works, right? You need to have unique identifiers. Think of like a hash map or dictionary in Python or well, any language, right? You want something, some sort of key that indicates what the rest of that is. If you took the databases class, you'll go more into detail on how SQL handles everything. But in a database, you need at least one primary key, and those primary keys together should map to exactly one object. So in this case, your ID maps to exactly one restaurant. And then the last thing, of course, is to delete the restaurant, and then this Boolean value is just true or false, depending on whether everything went through okay. And yeah, that's what schema is over here. Essentially, this is telling GraphQL what each of these commands should indicate. So then when you go to app.js, you can do something just like this, and then all of this will make sense to the backend. Okay, now I believe the last component of this is the resolvers. And essentially what that is creating each one of these functions. So right now we like instantiated them in a sense, right? Now we just need to write their function up. So resolvers.js. Here I'm gonna import restaurant from that models from this models over here that we created. And then now I'm just gonna create a list of all these resolvers. So the different resolvers that we need, remember the things that we created? We created the C up here for query, and then we created the R, U, and D for, sorry, no, we created the R up here in query, and then we created the C, U, and D down here in mutation. So the first thing that I want to do here is to create the query object, so essentially reading. So query, and then we're going to check oops, restaurants. Come on, there we go. So we're gonna have kind of what the function is doing, and then what the function is doing is it's taking in that restaurants object and then spitting out the information over here. So if we do restaurant.find, find is a filter within GraphQL that finds something inside a database, right? Sorry, not inside GraphQL. Find is a function that's with MongoDB. So find is like you have restaurant, which is your restaurant schema, right? So your schema contains all of this different information. And then when you call find on that, you have to pass in a filter, and then that filter is going to pull out the information that you want from there. So we're going to run restaurant.find, and then we need to input our filter. That filter is going to be a JSON, essentially. So I'm going to pass in this, and then a regex that's calling in the name of the restaurant, just so that there's a search functionality, right? Remember, if I go to this React app, I don't think it's running anymore. But if you remember back to when it was running, there's a search bar up there. So essentially, what this is saying is it's going to return all the restaurants that you want that are in accordance of this filter name. So that's what we have there. If you want, and this is optional, you could have another option here, and it's called options, and call that options I. All this means is that it's not case sensitive for your search, so it makes it a little bit more of a accurate search, I guess. Okay, so that's that. Um, and then we have this return. Now, what we need is to have the mutations object explained. So if I go down here, create this mutations. Remember back in the schema, we defined three of these. We made create, update, and delete. So if you want to create a new one, that takes in an input, and then you're going to create a new restaurant object with the I guess what the constructor input of input, right? And then you want to return that new object that you just created. And how you do that in MongoDB is you need to create that object and then call dot save. So the two main things that we've done so far, dot find is to find something with a certain filter. Dot save is to save that into the database itself. So when you create something, you want to save that. And for all of these, we want to save, right? Just because saving, you want that to actually register inside the cluster once you create that. Next thing that you want is this update restaurant. That's going to take in an ID and then an input. And then what you want to do is another really convenient function in MongoDB that's called find by ID and then update. Um, it is very conveniently named because that's exactly what it does, right? So that's this input over here, essentially saying that you take in the ID, you take in the input as a second parameter, and then this new equals true over here basically says that if this ID is not found inside the database already, then what you want to do is to add that as a new object that isn't already there. And Copilot's doing everything for us. I think for next workshop, I'm going to turn that off just so I'm not like speeding through everything. But the last thing that you want is delete. Um, oh yeah, I need to call me here. But the last thing that you want is delete. And yeah, uh, which is essentially calling find by ID and delete. All of these different functions, I would say you get used to them when you're actually doing more MongoDB stuff. But if you're doing something for like a hackathon and you're just getting started with Mongo, or like you just need something more introductory, which you can really, I guess, focus on here. Yeah. What you can really focus on here is these so far. So find is kind of a search feature. Save is actually creating an object. Find by ID, uh, find by ID and update, find by ID and delete. I think there's another one, find by ID and um, replace, or I think it's called find by ID and replace, but it's slightly different from update. I forgot what the exact nuance is, but there's a bunch of those out there that are just really convenient. Um, the point of MongoDB is that you're not writing plain SQL. Um, like for example, if you wanted to do dot save with plain SQL, you do insert into restaurants, and then you would have the information that you're inserting, right? Spaced by commas. So then you would probably, if you were doing this without MongoDB with plain SQL, you'd have some other file here that contains all of these different SQL phrases, and then you'd have to plug and chug them into your code. But Mongo makes this really convenient in the sense that all we need to really call is on the restaurant object, we need to call find by ID and update, and then that's all we have. So, I think that's everything that we need in here. The last thing I will have is an export default resolvers. All that says is that if all that says is that we can import that in another file. One other thing I need to add, let me see if I already have it. Okay, I think I already have it. I was gonna say that one thing that we have is that if the name that we're filtering for is empty, then you want to return everything because that's just how search features generally work, right? But I think that there's like a ternary expression here. If you don't know how that works, essentially that's just saying if this name object is null, then return this empty list, right? So yeah. Um, let me just make sure that's everything real quick. I believe just to really go over everything, we have the restaurant object here, which is essentially the schema, the backbone of everything that's being created. We have the schema.js file, which is kind of telling GraphQL what's going on with these different phrases. So menu item is this object that's going to take in all this information. Mutation is these three functions, right? So then when we go to our app.js front end, all you have to call is, let's see, I can find a better example here. Yeah, you call mutation, you call restaurant input, which is another thing that we created before, and then you call create restaurant on this input that we declared before. So again, that's more front end stuff, but I guess this is kind of how that front end intertwines with the back end. And the whole reason that we're using GraphQL is so that this is one string rather than a bunch of different strings and steps that you would use with plain SQL. But yeah, I believe I'm just checking through everything. That's all done. Um, oh yeah, one really important thing is that we need to set up the server for this. So remember those endpoints. It's more Node.js focused, but these different endpoints right now they're connected towards um, each of these different URLs and endpoints, right? For example, we have an endpoint to post to restaurant. Now that we're using GraphQL, all we need is one endpoint, and that's going to be down here. So if I take this here, it's like only a couple lines now. It's not, I think it was like 50 before. I want to, I guess, remove that for now, just so you're not stealing the key there. But you would have this key over here that has access to your cluster. That cluster information you can get from over here. I think it's let me see. I think it's connect new, and then you would get this key over here and then copy paste that into there if you're doing that by hand for the first time. But you'd get that Mongo URI. It's mongoose.connect, and then you have like this then and then catch, essentially just Node.js telling you in case that there's an error. And then the last thing is that I'm going to be listening on port 4000 just because I already have 3001 running. So just to split that up, you have this app that's running there. And then now I believe, let me just make sure in app.js that this is also running on 4000. Yeah, it's running on 4000 with slash GraphQL, which is slash GraphQL. Okay, yeah, so those two things should be matched up now. And hopefully it runs. Um, if it doesn't run, then that's not good. But yeah. Okay, so it says ready to run 4000, connected to MongoDB. Good. Okay, there we go. That's good. So now it says burrito place. Hopefully if I reload, that doesn't go away. You can see the different things there. I'm just gonna make sure that when you add a restaurant, let's call it, I don't know, Taco Town, 123 5 4 6 Taco Street. Just put some information there. Yeah, that should be logged there now because we did a dot save, so then it saves to the database. I think if you look in the clusters here, somewhere. Um, I remember it being really hard to find these. I don't know why they do this, but like to access the actual data, let's see, visualize data. Where? Oh, here. Hopefully. We'll see. Oh, there we go. Nice catch. Yeah, I remember like I struggled the first time. This UI is there's so many things going on. But yeah, th that's the new one that we added, Taco Town, 1246 Taco Street. Um, Pretty convenient there. If I added something else, it would do the same thing, access that endpoint. Um, yeah, I guess the only downside to using a database is that now you need internet access because this is cloud. Um, but I don't think that's like if you're making an app shop application, hopefully you have internet access. I believe there is a way to make Mongo locally based. Um, I think. I just don't think I've used it before and it's kind of annoying to set up. Postgres is another database. I've used that in the past. That uses something called pgadmin. Let me actually see it. If I have pgadmin here. Okay, maybe not on this. But yeah, PG admin, it's their UI is straight garbage. Like it's even worse than this. At least this looks like nice and modern or something. Just wait till you see PG admin. You have like all these different folders and directories inside each other. And then to access some information, you need to put in some SQL code to actually even read the data inside there to begin with. But I think that's what most a lot of these like legacy code companies use Postgres more. The thing with Mongo is that it's a relational database. Um, think of that as like we have this restaurant object and then we have a bunch of these restaurant objects. And then inside each restaurant object, we have a bunch of these menu items. So we have like actual objects that are like common. They have common properties. Non-relational databases. I think Postgres is non-relational. I might be wrong on that. Um, I know there's a bunch of other non-relational ones. That's essentially just storing data regardless of what it is. There's no sort of meaning or schema that you need to really address. It's just like a straight database. Think of like a text file that you're writing things onto. So yeah, I believe that's everything. I know I kind of went through everything kind of quickly, but I think I just wanted to really focus on the back end more. Any questions from people? I know someone was online before. Or you guys? Yeah.
How do you actually doing the GraphQL?
Huh?
How do you actually capturing the requests?
Capturing requests. Yeah. So when I if I start from the front end, right, we have a fetch graph over here that's kind of fetching that endpoint. So then when you call uh fetch graph on this query over here, that's first gonna go to server. It's gonna catch this. And then it's going to where is the line? Yeah, it's going to connect to the Apollo server. Apollo server is another word for GraphQL. That's just the like a middleware, if you know what that means. That goes in between things. So once it um gets that query, then it checks the schema string for what that query was. It breaks it down kind of like a parser, right? And then it interprets that. And then once it knows those things, then it goes to the resolvers to get the different functions and see what those mean, and then return the actual value. Uh, yeah, then it returns the actual value through the server. I think that's just I think that's also handled in Apollo server, my bad. But yeah, then that makes its way back into the app.js file.
You would cover like the query.
This query?
Yeah.
Yeah, sure. So if you look at this one here, query, if you go to query, I believe this is under this is for the search bar. Um, so if you go to the server, sorry, schema, query that we made here, we made something called restaurants and restaurant. Restaurants gets a list of restaurants, restaurant gets a singular restaurant. So when we call query on that query line, that's going to access this resolver over here, with a single input for the name, and then it pulls whatever restaurant or restaurants that go under that filter and then returns that object. Um, it returns that object here, and then the front end figures that out. Cool. Any other questions? Awesome. So yeah, that's really all I had. If you have any other questions, feel free to ask them. But yeah, other than that, that's good.